So now if we start to take a look at our next subsection for today, which is quantitative reasoning. And so for quantitative reasoning, what I'm going to do is give you a little bit of an overview, and then I'm going to hand over to Joe, who's going to help you out with a tutorial for using the UCAT calculator. So far, how do we all feel about the UCAT calculator? Do we know how to use it? M plus, M minus? How do we feel about it? The memory function is weird and you really struggle. Okay, so hopefully that should be very helpful when Joe is now going to give you a really quick walkthrough in terms of how you use the three memory functions and where they might be helpful. But before we start that, if we just have a general overview with quantitative reasoning. So we've got 36 questions to answer in 25 minutes.
Oh,
And
Jess.
that means you want to have about
Oh, Jess, I'm so sorry. I was just going to suggest maybe just for like 30 seconds to a minute, we could just have a super quick eye break for everyone, just to take like a little breather, because there was so much helpful information there. Literally, guys, I'm just going to set my timer for 1 minute. Everyone can turn off their cameras, feel free,
yeah,
just to give
let's do it.
everyone
Sounds
like a
good.
little break for a second. So, guys, we'll be back in 1 minute.
We can even make it like five if we need to, because we're doing quite well for time. So we could make it, let's do like 10 past if people want.
Guys, would you prefer like a 1 or 2 minute break or a 10 minute break? What is everyone thinking would be better? If you just 5 minutes, 10.
5 minutes, 10. Okay, people seem to like 10 past. So well, it's a
Oh,
mix actually.
it seems five is the most popular answer.
Five, okay, let's do five then. 12:08. See you all at 12:08. And just to point out, if you were worried about having time to fill in the form, as I know someone said that, we're going to have a lunch break between 1 to 2 p.m. So you can fill in the form then as well if you're not getting it working now. So don't worry, loads of time for that. And so, Ellie, what we're going to do is until 2 o'clock, we're going to do some quantitative reasoning. And then we're going to have a lunch break. And we come back at 2 o'clock and then we go till 4:30. So between 1 and 2 p.m., you've got your lunch break, and then we finish properly at 4:30. Guys, I know you're saying you're being aired. I mean, this was a break for us as well. So sorry if I didn't answer some of your questions. But yeah, we are going to be recording this. And yes, we will be sharing out the slides. Now, I'm not entirely sure whether we're going to be able to post the entire recording because it does depend on safeguarding stuff. And if we have kind of your name showing up for any of it, then we wouldn't record that and we wouldn't share the recording for that. But potentially we get the recording out to you. And if not, then we definitely get the slides out. So don't worry, you will get the slides and hopefully the recording. And to make sure that that happens, the best thing you want to do is fill in that questionnaire. So if you fill in the questionnaire, then we'll have your email address. And if we do share the recording, then 100% you'll get access to it. And we'll try our best. We do have it on record right now. We just might need to edit out certain bits for safeguarding reasons. Okay, so I think we said 8 past, so let's get started now. And so if anyone's not here, don't worry, you won't miss too much. And Hassan, with regards to your question, we've just done VR so far. So you've not missed much, you've just missed a little bit of verbal reasoning. So for quantitative reasoning, what we have is 36 questions, 25 minutes. That's about 40 seconds per question. Now, what you want to make sure is you don't try and answer all 36 questions in order 1 to 36. Because with QR, what you can do is it's really easy to recognize what question might take you a little bit longer and what question maybe won't take you quite as long. And the kind of things you might look out for is the number of words in the question and the number of calculation steps you think it's going to need. And if you find that one question is going to have maybe 6 or 7 steps of calculation and it's going to take you a little while, that's the kind of question you want to skip and come back to. Now, even if you find that you're going to get them all answered, like I remember for my QR, I did in the end answer all 36. I still didn't do it all in a row, 1 to 36. So the ones that I thought were going to be a little bit trickier, I made sure to come back to just in case. Because what you don't want to happen is for some of the easier questions at the end to get missed out. So don't risk that. And the other thing that's super important is to make sure you're practicing with the UCAT calculator. So we're going to be doing a bit of that now. And before we get started with that, just a quick reminder as to what the areas are that can be examined in UCAT quantitative reasoning. So we've got percentages, unit conversions, rates and averages, area and volume, and then speed, distance, time. So these are the main areas that are going to come up for your quantitative reasoning. And if you find that there are any of these areas that you don't really understand, then it's a really good idea to first figure them out. And you may want to go back to, say, some GCSE resources if needed. Like you might want to take a look at Corbett Maths is a good website we sometimes recommend, and figure out how to do them and then speed them up. And there's absolutely no shame if you need to go back and figure out some of these topics. That's completely okay because it might have been a while since you did your GCSEs last time. If possible, go back and cover these topics. But if you find that you know how to do them and the only issue is timing, well, in that case, you just want to focus on timed practice with the UCAT website. And in that case, you want to make sure you're practicing using the UCAT calculator. So, one thing you want to keep in mind, like we said, tricky questions, how we're going to avoid those. What do they look like? Maybe if the question is long, if there are loads of steps to calculate, and also if the answer options are really close together. Because if the answer options are close together, then it means you probably can't guess and estimate. You actually have to be exact. And the last kind of thing you might want to look for is if your numbers are a little bit irregular. So say rather than having 20 and 10, if you had like 15 pounds 64. And if you had something like that, it's going to be a little bit trickier to do in your head. Now, someone has asked, Sana, would you recommend skipping tax bracket questions? So what I would say is we're going to have a look at some tax bracket questions now. And I think we have Joe ready to get started with that. So, Joe, are you around?
Yes, fantastic. Let me just take over
Yes.
screen
So you're
share.
not going to skip all the tax bracket questions because after today, Joe is going to teach you how to do a great job with them. So if you learn how to do them, should be okay.
Perfect. So I should be screen sharing in just a second, guys. So can everyone see that all right? And we'll start on some
Yeah,
questions.
that's great, Joe.
Great, thank you very much. So building on what Ojas has expertly talked about, let's take a look at a question. And remember this theme of rounding and finding round numbers and estimation. And so if everyone takes 40 seconds to a minute to take a look at this question and think about how you'd approach this and direct message me with your answer from A to E down here. So we can see there's a lot of information there. You can completely cross out that table. It's giving you all sorts of information that you don't really need to use once you read this question. And remember, the strategic theme here is estimation and moving past all the excess info and tables and statistics that you don't need. Just focus on that question. So I can see I'm getting lots of answers. Thank you.
Hey guys, please remember to DM Joe with your answers if possible, just so everyone gets a chance to kind of think before it pops up. So just a reminder, DM Joe your answers.
So great, guys. Thank you. I think lots of people are identifying that there is a common answer. So that's E, so 207 million. And the first thing to look at here really is you've got 5 answers that are really far apart. So then they're not even in the same league, are they? You've got 129,000, 2 million, 12 million, 20 million, 207 million. So they're completely different quantities. So we know we can really rely on our rounding and mental maths essentially here. So let's take a look. So we're asked to work out 10% of the 10% of the population. So we just look at the population, we see it's 51 million. So because the answers are so far apart, we can round that to 50 million, work out 10%, And then we know each vaccine is £40, isn't it? Here, £40. So we can do some simple multiplication to do 50 times 40 gives us 200. So 200 million. So are people happy with how we go about answering that? I'm just trying to, there we go. So all that's needed is your 50 million here. Ignore the excess information that's just there to distract you and focus on that. Focus on what the question asks and try and identify that nice and concisely from the question. So now we'll move on to some calculated demonstrations. So let me just, I'm going to share with you the screen. Let's see, directly from the UCAT website. So can everyone see here? I'm on the UCAT website. Many of you will probably have taken a look at this already. Pearson VUE, it's their specimen questions for the UCAT quantitative reasoning. And first of all, this is essentially what you'll see in your exam. So you'll be sat down in your exam and you'll have a large keyboard. So let's just go back to the slides as it gives a little bit of info. So you must practice using the calculator. That's essential. Don't fall into the trap of using the calculator you use in your maths lessons, A-level maths. You'll have a nice scientific calculator, be easy to punch numbers in, save your numbers and do complex calculations. But UCAT, you don't have that. You've got this really bulky, difficult to use calculator. So get used to using it and don't be over reliant on it is another tip. So often you can think, okay, I really need to use my calculator. It's there. I want to have the exact answer, make sure I don't get this wrong. But in reality, as we saw with the last question, when you can identify that answers are far apart, often you can just round numbers, do that mental maths in your head if you can. So don't be over reliant on the calculator, but it is a really important tool when you need to use it. So what we do know is, as said on the slide here, clicking on the numbers is very slow. You'll have a mouse in your exam, so it makes it a bit faster than using a mouse pad perhaps, but it's still very cumbersome and takes up a lot of time when you've only got 40 seconds per question in the quantitative reasoning. So there's a few shortcuts we've got here. So the first shortcut is Alt-C. So if you press Alt-C in your exam, it will bring that calculator up straight away. Alt-C again, and it'll take the calculator away. So that's the first thing to remember. I'll flick back over now to the calculator just to show you. And here we go. So Alt-C, I've actually not got an Alt on my keyboard, so I'm going to click on it. So let's have a go at this tax question and let's talk about some of the things. In fact, before we do that, we'll do the calculation we just had on the screen. So we want to work out 14/15 plus 16/17, or 14/15 plus 16/17. So how would we go about working that out? And that's pretty tricky to do on paper or just in your head. I think everyone would agree. So thank you very much to Ojas for annotating that on the screen. So we've got three functions here, MRC, M minus, and M plus. Now these will help you really when it comes to using the calculator. So MRC is memory recall, M minus, memory subtract, M plus, memory add. So say we have a number. So we've got 14/15. So I put in 14 over, let me just clear that, 14/15. We've got this number. Now, what we can do to add that to our memory, just select memory addition. Now that's in our memory. We can then clear and do 16/17. And you've got your answer for 16/17. Now, how do we add the number we've just put into memory recall? Well, we just press memory plus, and that should give us, forgive me, so there we go. And now we go memory recall, and that gives us our answer. So it really helps to use these shortcuts. If you get familiar with them, it can really save a lot of time. So if we just flip back, we can see the letter P you can use for memory addition, M for memory subtract, and C for memory recall. So if you get familiar with using P, M, and C with the calculator, it can really help. So now let's move on to do the number of TB cases. So we wanted to do percentage increase. So what's the percentage increase in the number of TB cases? So can anyone try and work that one out? The number of percentage increases. So we went from 129 million to 199 million. So if people in the chat can send over their answer for that, if they've got...
Joe, there's just been a couple of requests for you to just show it again, if that's...
Of course, yeah. I'll flip back to the calculator. So let's show you in the context of that last fraction. So say we've got this memory recall button. This brings back the number we've saved in our memory at any time. So I press on it, it brings the number back. Now, if I press twice, it clears it. So we then lose it. So if I clear the calculator, say I've got a number I want to work out, we'll use 14 over 15 again. That gives us this decimal. So I want to add that to my memory plus. And now if I clear my calculator, I can recall that at any point using the MRC button. Now, if I want to work something else out and subtract it from my memory, for example, 78 over 94, I just press, I want to subtract this from my previous value in memory recall. I just hit that and it gives me this. So we get a final number there. And then to add that to my memory recall, there you go. So are people happy generally? And now if I want to clear memory recall, remember, you just press it one more time. So press it once to bring it up and then twice to clear it. Now, if you want to clear your calculator quicker than, I know I'm using the mouse on screen now, but what you can just do is say I have a large value up, such as this. I want to clear it. I can just press 0 equals 0 and it should clear it. So at any time, if you put 0 equals 0 on the calculator, it will clear the calculator. So does anyone have any questions about using the calculator? Are people generally happy? I can see someone saying, say you get a new answer and want to store it in the MRC, but you already have something stored in there previously pressing M+. How would you do this? So you can clear your MRC. The best way to do that is clear your memory recall first and then store it in. You can only ever store one value. So perfect. Yeah, thank you very much for people helping out there. And now we'll move on to using these skills to answer a question. So here in front of us, we've got a tax question. And I don't know how comfortable people are generally with tax questions, but they can pose one of the more difficult question types. So tax questions and interest questions are the more difficult question types that many people report on the quantitative reasoning. And they work in very similar ways. Essentially, one's just the reverse of the other. So here we've got a question, and we've got a number of tax brackets on the screen in the table. So the key here is you really want to identify what tax bracket this person falls into. So we've got their annual income here, 28,950. And the key is understanding how taxes work. So don't ever make the trap or fall into the trap of thinking that someone is only in one tax bracket. So remember that people fall across tax brackets. So the first £8,950 you earn, you pay 10% tax. And then any money you earn over 8,950 up to 36,250, you pay 15% tax. So it's remembering that no one falls into one single tax bracket. You fall across the tax brackets and you move upwards like this. So knowing that, I'll give everyone a chance, 40 seconds, just to have a crack at this question and direct message me the answer when you're done. And I can see some answers coming up in the chat. Thank you very much. Thank you to everyone who's sending some answers. Yeah, they're all really good.
Please remember to DM Joe with your answers, guys, just so everyone has a chance to think about it.
So I think everyone's had a chance now to have a crack at that. So we'll begin talking through it. And I can see lots of people have said B, and that is, yeah, really well done. Correct. So let's talk about how we got there. And this is another great example of a question where you can cut corners and save time. You don't need to be punching all of these numbers into the calculator, which will just eat up seconds and minutes eventually. So we've got a person who's earning 28,950. So the immediate thing to recognize when you see this question is they're earning 28,950 and the bottom tax bracket ends at 8,950. So what we can do there is recognize they're only earning £20,000 more than that bottom tax bracket. So it's very round numbers. So we've got £20,000 only that falls into this top tax bracket. So we've got the first £10,000, the first 10,000. Apologies, my ability to draw on the screen isn't very good. Falls at 10%. Now the next 20,000 falls at 15%. And now that's really a calculation you can be doing in your head, isn't it? So 15% of 20,000. What have we got there? Exactly. So we can work it out. So we know that we're paying £895 already. Add that to 3,000. That gives us the answer, 3,895. So although tax questions can be quite complex, often you will have workarounds like this where you can essentially use your mental maths, or there are strategies to save time. Now I'll just clear this. We'll get back to the slides and take a look. So we've answered this question. We've gone through why it's 3,895. Are people happy with that generally? Are people happy with the idea? If people want us to go over it, okay. Let's talk about it again. So we've got tax bracket. Tax where it's called
So there's just a few requests to redo it, if that's okay, to just talk
of
back
course,
through it
yeah.
again.
Let's talk for it. So the way we do tax is called marginal brackets. So say I earn £40,000. So I'm earning £40,000, and these are the tax brackets that I'm falling across. So thank you, Ojas, for annotating. So exactly the first £8,950 I earn is taxed in the bottom bracket of 10%. So I only have to pay 10% of that first £8,950 I earn. Now the next amount I earn, everything from 8,950 up to £36,250 is taxed at 15%. That's what this is telling you here. And that means if I earn over 36,250, I'll be paying £4,990 in total. Now it's very important with these tables to pay attention to the heading in each table. So it tells you the total tax paid at the top of this taxable income bracket. That's telling you the total tax you pay overall, not just the total tax within that bracket. So what you don't need to do is then add 895 to 4,990. So all you have to do is work out which tax bracket you fall into at the top of your income. So £40,000. Work out the difference. So how far are you into this 36,000 to 87,000 tax bracket? And then work out 25% of that and add it to your total already accumulated in the bottom two brackets below. So does that make sense to people? It can be a bit of a difficult concept, I think, when you first come across these, but the more you practice it, I think the easier it will get over time. So it is a bit confusing, I agree. And interest can work in the same way, where you might pay a certain percentage of interest on the amount of money you deposit in your bank or spend up to, say, £8,000, and then you might pay a lower rate of interest or a higher rate of interest. So it can be very similar. So you might see similar questions worked regarding interest. Does anyone have any specific questions they want to go over with me regarding that, or are people happy? Okay, we'll move on to the next slide. So here we've got what could potentially be quite a tricky question. And we want to think about what is the trick here to save lots of time. So I'm going to give everyone a minute just to have an attempt at this question, read through it, and think about how you're going to approach this. And is there any way you can save yourself some time that you can notice when reading through the question, and maybe not do loads of working out? Just have a think. So remember to direct message me your answer when people are great. So I'm getting through some answers, and a bit of working out. Sorry, I skipped a question there. So great. I think everyone is sending some answers in. Fantastic. Thank you. So I think lots of people have sent answers in, and many people are saying E, and that's correct. So how do we get there? So I think when you first look at this question, it could be your instinct to, okay, you need to work out how much the mean weight will increase. So you're thinking, do I need to work out the mean weight for every box before? So add them up and then divide by 5, and then work out the weights when you add 6 kg to 4 of the boxes, and then work out the mean weights again. Now that could get you down a whole tangent where you end up doing plenty of working out, and it takes you quite a long time. It's quite time consuming. So let's think about a workaround here that might possibly work. So someone immediately said, was it 24 over 5? And now that's perfect, isn't it? So what we really need to work out here is just how much will the mean weight increase. And we're already told exactly how much weight's being added. So we've got 6 kilos added to 4 boxes. So what is that total? 24, exactly. So we're only adding 24 boxes. And because remember, our calculation for mean just takes into account the total weight and the total number. So we don't need to work out individual weights once you've had 6 kilos, do we? We can just add 24, divide by the total number of boxes, 5, and that gives us the answer. So often you will have these questions that might suggest that you need to go into loads of detail and work through, the individual change, but just take a step back sometimes and try and think, is there something I can do to work around individually going through each calculation? So let's see what we've got next up. So we've got another slide. I don't know, Ojas, if you want to talk through this slide, if you're familiar with these questions.
Yeah, absolutely can do. But thank you so much for that amazing introduction to the UCAT calculator. And I'm sure the people in the chat will agree. Some people are saying they don't understand the last one, so I could do the last one if that's helpful.
Yeah, that
What
would
do
be
people
great.
in the chat think?
Brief.
Should we talk about the last one a bit more, or should we do something else? Yes, okay, right. Let's have a look at the last one again then. I've just stopped your screen sharing, Joe. Okay, so what we're saying here is we have these 5 boxes, A, B, C, D, and E, and they have certain weights. And to start off with, we have a certain mean weight of the 5 boxes. So to work that out, we would have A plus B plus C plus D plus E, and we divide that by 5. Now that's the old mean. And what we're saying is we're adding 6 kilograms to each of these boxes, A to D. So we're adding 6 to A, 6 to B, 6 to C, and 6 to D. And so how we would write the new one would be like A plus 6 plus B plus 6 plus C plus 6 plus D plus 6 plus E plus 6 divided by 5. Now, if you take a look, we're just looking for how much do we increase by? How much is the difference? Well, A plus 6 plus B plus 6 plus C plus 6, so on, is just the same as doing, well, A plus B plus C plus D plus E, add on your 4 times 6. So add on your 24. So what we're saying is across all the boxes, A, B, C, D, and E, we're adding on a total of 24 kilograms. So we're adding 6 kilograms to A, B, C, and D. We're adding on a total of 24 kilograms. So in terms of what the difference is going to be, on average, across 5 of them, it'll be 24 by 5, because that's how much extra we have per box. So in total, we've got 24 extra, but the 24 extra is being divided between 5 different boxes. So in terms of what's the increase by, it's going to be 24 by 5. And if you think about this being the old mean and this being the new mean, you can see that these two numbers are exactly the same. It's just you've added on 24 by 5. So does that make sense or not? Yeah, no, what do we think? Oh, and people are asking why didn't we do E by 6? Reason why we're not doing E by 6 is because we're not adding on 6 kilograms to E. It's just saying 6 kilograms to A, B, C, and D. So that's why we're only adding on 24, not 30. So the answer to 24 by 5 is going to be, well, 20 by 5, which is 4, add on 4 by 5, which is 0.8. So 4.8 kilograms, B. But are people happy with why we're adding on 24 and not 30? Yeah. And someone has said, why can't you just add on 24? Because we're not adding on 24 to each box. We're adding 24 across 5 boxes. So on average, we're only adding 24 by 5 to each one. Now, if we were adding 24 to every single box, then yeah, it would go up by 24. But we're only adding on 6 to 4 of them. So I hope that makes sense. Now, for the next question, apparently Joe said it was E. I'm not sure. Maybe he said that by accident, but what he meant to say was A, B, C, and D. So the answer was 4.8, just like he said.
Yeah, apologies,
Now, do you
guys.
have
I read the wrong thing.
Oh right, no worries. Yeah, but it's only A, B, C, and D. Never mind. So now what would you guys like? Do you want to do the next question from here, which is a little bit tricky, or would you like to do another tax question? What do we think? Tax question. Okay, let's do another tax question then, rather than starting something new. So what I'm gonna do is head to the UCAT website myself. And so let's try the exact same one as before, but like a different one in that set. So we'll go to the same place. Right. So let's try this exact same thing. Same like before, but he's not got an income of 28,000. This guy has an income, let's say, of $50,000. So this guy making $50,000. And what we're saying is the way that these tax brackets work is you work up from the bottom and you only pay tax on however much money you have in each bracket. So imagine we're starting at 0 and we're told that the first bracket goes from 0 to 8,950. So what we're saying is however much money is in this bracket, we're going to be paying 10% of that. And it actually already tells you what 10% of that is in the question. So we know that's going to be 895. What we're saying then is however much money you make between 800, 950, 8,000 and 36,250, however much money is in here, we're saying that you pay 15% of that. So it actually does tell you what the sum is, but just imagine it didn't give you these answers. We're going to work it out from scratch just to show you how you would do that. So we're going to say that we have to pay 15% on the money between 8,950 and 36,250. And what we're saying is any money you make beyond that, you have to pay 25% tax on any money beyond that. So first thing we might want to do is figure out how much money is in each of these brackets. So first we filled up the first tax bracket, and the first tax bracket was your first £8,950. And we paid the 10% on that, that's 895, that's sorted. Now what we might want to do is work out the next tax bracket. So to start off with, I've got my 895 on the calculator, and I'm going to add that to memory because we've already worked that out. So I've done the letter P, and my 895 have already gone in the memory. Now what I want to work out is how much money is in my second tax bracket. So how much is in between 36,250 and 8,950. So to do that, I'm just going to subtract 36,250, take away 8,950. And well, we know that that's 27,300. Now, we only pay 15% tax on the money in this bracket. So we can times by 0.15, which we know is 40.95. Now, what I'm going to do is I'm going to add this money to the memory as well, because we're trying to work out the total tax on 50,000. So we've added the first bracket, and now I'm going to add the second bracket to memory as well by pressing the letter P again. So P for M plus, add the value on your screen to the memory. And now what we've got to figure out is how much money is left that we still have to pay tax on. So we've paid tax on the first 36,250. How much is left? What do we think? And yes, you are correct, by the way, Amira. You just need the letter P for memory. My laptop is about to shut down, apparently. That's not a good sign. But if someone could quickly point out, what do you think about how much money is left? Yeah, Halima, very good. So 50,000, take away 36,250. So we've worked out on the first 36,250 how much tax we have to pay. We've already done that. So now we have to think about how much money have we not paid tax on yet. And that's the stuff above 36,250. So we're going to do 50,000, take away 36,250. And I'll write that again. 50,000, take away 36,250. And we know that that is 13,750. So I don't know why I didn't type that incorrectly. Right. So what's happening? And this is why basically the UCAT calculator is not amazing, because you can end up typing stuff in wrong. And when you do that, you might waste some time. So in this case, we've got 13,750, which is in the tax bracket above 36,250. And we've said that on the money above 36,250, we pay 25%. Now, what you could do is times by 0.25. But when you do that, you're quite likely to type something in wrong. So what I would do is just divide by 4. Now, obviously, timesing by 0.25 and dividing by 4 is the same thing, but this requires fewer numbers. So now we've worked out the top bracket. I'm going to add that to memory as well by pressing the letter P. And so now I've got the sum of the three amounts of tax in my memory. How am I going to bring it up? What do you think? So how am I going to work out the last thing in the memory? Good, MRC. And what's the shortcut for MRC? So how am I going to do that with my keyboard? What's the shortcut? So just the letter C. Very good. Not Alt C, just the letter C. So I press the letter C, and the answer is 8427.5. So if I'm working out tax on £50,000, is going to be 8427.5. And one person told me the answer like 5 minutes ago. So very well done for doing it so quickly. Is there a shortcut for using the multiplying and dividing? Yes, there is a shortcut. So the shortcut is on your number pad. So if you have a number pad, then we have a shortcut over here. This thingy. So on the real exam, you get a number pad and it looks like this. So you can see that this is the shortcut for multiply and this is the shortcut for divide. Now, if you don't have one of these, I would firstly recommend see if you can borrow one or maybe practice at the library, because that's the kind of computer you get on the UCAT. But otherwise, you can also use the top row of your keyboard. So if you press Shift and the number 8, then you get the same star thing. So Shift and 8, and that's also going to give you multiply. But I would recommend practicing with this number pad if possible. That's quite helpful. Right, someone asking compound interest. Really quickly, yes, we can talk about compound interest as well if needed. And Danielle, you're saying red sheet currently covers max tax paid. Yes, you're correct. I just intentionally didn't use that because I wanted to explain the taxes. But Danielle, yeah, you're correct. So correct, make sure numlock is turned off. Good. So you guys have a choice, compound interest or proportions. What do we think? Both, okay, it's pretty much 50-50. Let's start with proportions then, because proportions is what I've got planned as the next question. And we can always look at some compound interest afterwards as well. So this one here is a very tricky question. And if you don't get this right away, I don't mean anything bad from, like, it's nothing bad if you don't get this right away. This is a question that a lot of people get wrong first time round. So have a try. I'll give you maybe like a minute to think about it. And then if you're not too sure, then we'll have a chat. And remember, just like Joe said, do not message to everyone. Make sure you click my name and direct message to me so you don't ruin other people's chances. But what you can do is if you're sure or you're not sure, just put them there. Okay, so people seem to be struggling with this one, which was expected. That's why I've picked this one out. So what we're talking about with this one is specifically all about inverse and direct proportion. Now, what you're actually going to find is all that information they gave you here. None of it we need. It has got nothing to do with the question. So this information here was a complete waste of time. All we need to think about is what we know about speed, distance, and time. So speed is equal to distance divided by time. And what we say is speed, when we have fixed distance, speed is inversely proportional to time. So what that means is if someone is going twice as fast, they're going to take half the time. If someone is going 3 times as fast, they're going to take 1/3 the time. And if someone is going to go two-thirds as fast, what's the time going to be? What do we think? So if someone is 2/3 as fast, what's the time? Really good, everyone. 3/2. So speed is inversely proportional to time at fixed distance. And that means whatever you do to the speed, you do the reciprocal to the time. So twice as fast, you're going to be half the time. Now that's the idea you're going to use here. Because what we've been told is that the second balloon, the rate of climb, so rate of climb means speed. And we're saying that the speed is 25% more for the second balloon relative to the first one. So if we start off with, if we said the rate of the climb is double, so it's twice as much, then what would the time be? So if the speed was twice as much, what would the time be? What do we think? Yeah, half. Really good. So now let's try for this one. It's not quite twice as much. It's 25% more. So if we have 25% more, well, that's multiplying by 125 over 100. That's the fraction you're multiplying by to get the speed of the second one from the first one. Now, before we even work anything out, let's see that if you were in a rush, how might you rule out some of these options? So our balloon is going 25% faster than the first balloon. So if the balloon is going faster, is it going to take more of the time or less of the time? What do we think? Balloons going faster, more time or less time? Less time. So we know that it can't possibly be D or E, right? Because if we're saying that it's going 25% faster, it can't be taking more time. It's got to be A, B, or C. So if you are really in a rush, you would pick one of A, B, or C, never D or E. So that should be a good place to start. Now, what we said is if you double the speed, you halve the time. So in this case, if we multiply the speed by 125 over 100, which is the same as 5/4, because 4 25s make 100. So if we multiply the speed by 5/4, then that means the time is being multiplied by 4/5. So remember, flip the fraction. Times by double the speed, half the time. Times by 5/4 the speed, 4/5 the time. And so if the balloon is taking 4/5 of the time, then which one of A, B, or C is that going to be? Really good, C. So someone asking, is this the kind of question you recommend skipping? I would say honestly, if you know how to do it, it should be okay. So 25% more, that means you're going at 5/4 the speed, which means you're going 4/5 the time. And then you pick 80%. I don't think that would necessarily take you too long. I think it's hard to get started with, but once you get the practice, it should be okay. And why 25 by 100? Because we're saying that the second balloon is 25% more. So if we were to get something is 25% more, imagine something was 100 pounds and we're trying to get 25% more, well, we would multiply by 1.25 to get 25% more. And to do these inverse and direct proportion questions, we use fractions. So instead of saying 1.25, well, I would say 125 over 100. But it's the same idea. If something is 100 pounds, 25% more, you times by 1.25. If something is 25% more speed, it's exactly the same thing. So that's where 125 over 100 comes from. And people asking, where did I get 5/4 from? Well, you've got 4 25s make 100. And that's just a good thing to remember for the UCAT. And well, we've got 4 25s make 100, 5 25s make 125. So 5/4. Everyone happy? How do you recognize if proportion is direct or inverse? Well, specifically, speed, distance, time is inverse. Inverse means if one thing goes up, the other one goes down. And that's like quite logical. If you double the speed, you halve the time. But for some stuff, maybe it's not going to be inverse, and you can probably work that out from context. Like if you imagine you've got people working in a factory. If you've got double the number of people, then you're going to make double the number of stuff. And so you just have to use logic a little bit. If you've got more people working on a job, you're going to do it faster. That's direct proportion. But if you've got speed and time, then that's going to be inverse proportion. You go faster, you take less time. Now, Amal, you're asking, is there a relationship between speed and distance? Well, you don't need to worry about the distance because the balloons fly to the same height. So for this one, you only really need to worry about time. Now, last person asking, can I do the question again? Let's just get like an idea. Are the majority of you happy with this or not really? Just put in the chat. Majority of you quite happy? Okay, I'll come back to this at 1 o'clock when we go on our break. And if anyone's not sure, then I'll just explain it then. I don't want to spend too long on the same question, so I'll come back if needed. Now, another thing we do before we go on to some more questions is I recommend you memorize some of these decimals. Now, that might sound like really obvious and something you can do on your calculator, but the reason why this is super important is, for example, if you get another question on speed, distance, and time, and say you have to work out that John travels 100 miles in 2 hours and 39 minutes. Well, to work out his speed in miles per hour, you're going to waste a lot of time if you try and use the calculator for everything and you work out 39 plus 120 divided by 60 to get the number of minutes. So if you had to convert minutes to hours on your calculator, that could waste time. And so what I recommend instead is that you memorize some of these decimals, and then it can help you with speed, distance, time questions. It can also help you with simplifying stuff. So for example, if we had the question 100 by 8, and we knew the decimal 1 by 8, then we know that that's just the same numbers, but with different place value. So the decimals that you probably know are like 0.25, 0.3333, 0.2. And so if we know that a quarter is 0.25, what's an eighth going to be? What do we think? Great, it's just half of a quarter. So 0.125, that's how you're going to remember it. If a third is 0.3 recurring, what's a ninth? Yeah, 0.1 recurring. Now, 1 by 6 is a little bit tricky, but it's easy to remember because it's got sixes in. So 1 by 6, 0.16666. That's how you remember. And 1 by 7, honestly, that's not a very round number. So if you don't want to remember this one, you can avoid it. But that's 0.143. Definitely try and memorize these ones though. So 1 by 4, 1 by 8, 1 by 9, 1 by 6. And how are you going to use them? Well, for example, if we have 20 minutes, that's a third of an hour. So 0.333. If you have 15 minutes, that's a quarter of an hour, 0.25. If you have 40 minutes, that's two-thirds of an hour. So 0.33 doubled, 0.666. If you have 12 minutes, that's a fifth of an hour, so 0.2. And if you have 10 minutes, that's a sixth of an hour, so 0.1666. Now, it might take a while to learn these, but once you've learned them, imagine you've got this question: John travels 100 miles in 2 hours, 39 minutes. Well, what are you going to divide by? And keeping in mind that we're allowed to estimate stuff, what are you going to divide by? So to work out John's speed, he's 100 miles, 2 hours, 39 minutes. What are we going to divide by? Yeah, really good. 2.6666. Because we know that 39 minutes is about 40 minutes, one of these numbers we memorized. So if John is going 100 miles in 2 hours, 39 minutes, that's just going to be 100 divided by 2.66. So that saves you the time of working it out on your calculator. You only do the last bit on your calculator. Make sense? All good? Okay, one last question then. Let's do quickly, and then we'll finish off for 1 o'clock. So, last question for today. Last one is a pretty easy one. The only thing to bear in mind is that the numbers here might be set up to trick you. So, watch out for any kinds of tricks and have a think what the answer here might be. So, remember, direct message, not put on the chat for everyone. And while you're figuring that out, Halima, just to answer your question, where I got 2.666 from, well, I said if we have 2 hours and 39 minutes, that's about the same as 2 hours and 40 minutes. And well, we decided that 40 minutes was two-thirds of an hour, and we memorized that that was 0.666 as a decimal. So that's just a number you have to learn off by heart. Right, so we have people saying slightly different numbers for this. What you have to keep in mind for this question, and this is a common trick I've seen on quite a few UCAT questions. Callum is cooking fish pie for himself and 9 of his friends. So how many people are eating fish pie? 10 people, not 9, but 10 people, because Callum has to eat 2. So himself and 9, that's 10 people. Now, we know that for 6 people, you have 300 grams. And if we're working out for 10 people, then we have to multiply by 10 by 6. So divide by 6 to get 1 person, multiply by 10 to get for 10 people. So 300 divided by 10 by 6. And you can do that in really any order you want. So you might want to start by dividing first. 300 by 6 is going to be 50. And then 50 times 10 is going to be 500. So really well done. I think most people got that right. And the people who said a bit less than 500, you probably multiplied by 9 by 6. And Vanessa, good question. Does the 9 Oz matter? No, it doesn't. So the 9 Oz was a distractor that you had to avoid. So the way you would approach this is you'd read the question first and you think, how much haddock does Callum need to buy? So you'd look at haddock and you'd see haddock, okay, 300 grams. And you then want to figure out maybe how many people do we have and how many people is the recipe for. So I'd specifically look for numbers about numbers of people. And I wouldn't waste time reading all of this. As soon as you see the numbers you think you need, you then start working it out. So like what time the guests show up doesn't really matter. And Shivani, you're right. This is more of a basic maths question, so this doesn't require anything to do with proportions. Why is it 10 by 6? Well, because to work out for each person, you've got 300 times by a sixth. And then to work out for 10 people, you times by 10. And well, 10 by 1 times 1 by 6 would be 10 by 6. Time question. Danielle, I'm not sure what you mean about time question. I can't see anything about time. Um, but I guess, yeah, you'd have to keep that in mind if the question was about time. Now, that's everything for today. So you guys can go on your lunch. But if you need to do anything else, or you need to ask me about any of the ones that we've done before, then do let me know.
Hey guys, just before lunch, I have a little halftime message. I'll just copy and paste it into the chat. But it's basically just some links to, if anyone has missed it, we're doing a pre-questionnaire and a post-questionnaire. It's really helpful for us to do better and also be able to get funding to be able to do stuff like this in the future and to provide it for free. I've also provided some links. Hang on a sec. So this is the first part, and then this is the second part. So if you guys are just chilling and want to, oh, I've also included the second half of the form, just so you guys can already fill it out for the sections we've already done. And then through the afternoon, you can kind of do the feedback for that section as you go along. So yeah, basically that's just there for you guys. We'll do the prize draw for everyone who does the pre and the post next week. If you just wait until the end of the day to do the post one, but kind of fill it out as you go along, that would be amazing. But yeah, well, thank you so, so much to Ojas and Joe. It's actually been incredible so far. I'm sure you guys will agree. They've done an amazing job, and all our volunteers. But we hope you guys have a lovely lunch break.